There's something wildly hypnotic about watching an object go from raw material to a finished product in minutes. And when it happens 1 million times a day, that's not just manufacturing, it's a spectacle. In the heart of a modern LED bulb factory, everything moves with a kind of controlled chaos. Conveyor belts whir, robotic arms zip back and forth, and components, tiny, delicate, precise, fall into place like magic. But behind that magic, it's a story of heat sinks, tiny yellow chips, molten plastic, glass domes, and a glowing wall of light where thousands of bulbs are tested in one epic moment. Let's take a walk. No, better yet, let's ride the assembly line. The birth of the body where heat meets shape. Before light can exist, it needs a home. That home, the LED bulb body. It's built to be strong, heat-resistant, and light-friendly. The process begins with placing the aluminum heat sink. That's not just any piece of metal. This is a vital part of the bulb that pulls away heat, keeping things cool even when the light's been on for hours. If it weren't there, the LED chip would burn out faster than you could say eco-friendly. After the heat sink is set, the base of the bulb starts taking shape through injection molding. Picture this: molten plastic, hot and gooey, being injected into perfectly shaped molds. In seconds, it cools and hardens into the shell that will eventually hold all the inner components. It's fast, precise, and oddly satisfying to watch. Now it's starting to look like something real, not just a blob of plastic and aluminum, but the beginning of something that will one day light up a room. The LED chip, tiny but mighty. At the heart of every LED bulb is a tiny yellow square, the LED chip. Don't let its size fool you. This is the real light maker. It's like the engine in a car or the CPU in a computer. Small but essential. The process kicks off with surface mount technology, or SMT, where these chips are delicately placed onto circuit boards with almost inhuman precision. Machines do this part because the chips are tiny, like really tiny. Trying to place them manually would be like threading a needle while blindfolded, with chopsticks. But for all the machine magic, there's still a human touch involved. Skilled workers step into solder wires onto the direct on-board DOB LEDPCBS. It's a careful process. Each connection matters. A single weak joint and the bulb might never shine. And then come the IC drivers, little integrated circuits that control how power flows through the bulb. These are separated, sorted, and soldered onto the LEDPCBS, again by hand. Not because machines can't do it, but because these drivers are delicate, and sometimes machines just don't have the finesse. Some LED bulbs are compact, with IC drivers so tightly packed that assembling them by hand is the only option. Add to that certain sockets like the B22, which require hand assembly because automated tools just can't handle the design. It's a blend of automation and craftsmanship that keeps the process flowing. The driver, invisible but essential. Ever wonder how a bulb handles the electricity straight from your wall outlet? That's where the driver comes in. It's the silent workhorse hidden in the base, making sure everything runs smoothly from the moment power hits the socket. Tucked away inside the bulb's foundation is a small but essential circuit board that acts like a translator in taking the high-voltage alternating current, AC, that flows through household wiring and converting it into the low-voltage, steady direct current, DC, that the LED chip requires to shine bright without burning out. Without this component, flipping the switch wouldn't do anything but send raw voltage to a chip that's just not built for it. The journey of the driver begins with delicate precision. First, there's the soldering. Wires must be connected to just the right points, with clean joints that won't fail or under long hours of use. It's not simply about connecting parts, it's about ensuring those connections can handle surges, dips, and constant current flow. The driver board itself is mounted with care, often by hand, especially in more compact bulb designs where machines can't easily reach. These tight configurations demand human finesse, and the workers handling this part are incredibly skilled at making sure every lead is placed perfectly. Some LED bulbs operate with external or modular IC drivers, which are small integrated chips that regulate power flow. Others go the compact route, embedding the driver directly onto the main board. Both approaches have their advantages, but what they share is the absolute need for reliability. These components have to survive thousands of on-off cycles, endure voltage fluctuations, and keep the light steady without flickering or overheating. At this point in the production line, the bulb's internals are beginning to sink. It's a small symphony of microcomponents now fully assembled, from chip to board, from wires to drivers. Electricity will enter at one end, travel through carefully soldered paths, get conditioned and converted by the driver, and finally reach the LED chip in just the right form. It's the technical heartbeat of the bulb. Yet, even with all this carefully crafted tech sealed inside, the bulb isn't quite finished. It still needs protection, polish, and proof that everything works the way it should. But for now, it stands as a fully wired promise, ready to turn energy into light with a single flip of a switch. The globe covering the light. With the engine ready and the wiring in place, the next step is to protect and shape the light. That's where the PC cover comes in, the dome-like cover that gives the bulb its familiar look and helps spread the light evenly. It's more than just a finishing touch, it's the diffuser, the final frontier between raw brightness and comfortable illumination. Depending on the design, this dome might be made from either plastic or glass, and each material brings its own character to the bulb. Plastic covers dominate most production lines due to their lightweight and durability, and the way they're made is nothing short of mesmerizing. The process begins with injection molding, molten plastic heated to the perfect temperature, then shot into molds that give it that smooth, curved shape. Once cooled, the covers are crystal clear or gently frosted, depending on the desired lighting effect. In some specialized production lines, the classic charm of glass is still used. It's a slower, more delicate process involving glass blowing, shaping the red-hot material into seamless domes before letting them cool into a pristine, transparent shell. Whether glass or plastic, each dome must be flawless. Any bubbles, warps, or scratches can affect how the light disperses. When ready, these domes are moved to the assembly line, where robotic arms take over. With sharp, precise movements, the arms grip each cover, rotate it gently, and lower it onto the bulb body. The alignment is spot on, no guesswork here, and the snap into place happens in one smooth, satisfying motion. But snapping alone isn't enough when the bulb will face years of heat and pressure. That's where adhesive comes in. A tiny bead of high-performance glue is applied at the base of the cover. It's clear, strong, and built to last. It ensures the dome doesn't shift, crack, or loosen over time. Once sealed, the bulb gets one step closer to completion. This entire process happens in seconds, repeated over and over across thousands of units per hour. And the result? A perfectly shaped light diffuser that not only protects the internals, but also softens and spreads the glow into something comfortable, familiar, and pleasant. The dome isn't just functional, it's what makes the bulb instantly recognizable on store shelves, and in every room it eventually lights up. Watching this part of the process unfold feels a bit like watching high-tech ballet, a dance between heat, precision, and polish. Semi-automatic magic, humans plus machines. Here's where things get really cool, the semi-automatic production line. It's part machine, part human, and all efficiency. Workers place the assembled PCB into the bulb base and feed it into the machine. It presses everything into place with just the right amount of force. The machine also leaves enough room for the PC cover to be added later. Spacing is everything here. Next comes the socket. Whether it's an E27 or B22 base, the socket is added and locked in. Some are screwed, some are clipped, but every one of them has to be snug. A loose socket is a safety hazard, and this process doesn't allow for mistakes. Even at this speed, rotating with thousands of bulbs moving per hour, every single one is handled with care. The aging rack, a wall of light. Now comes the moment of truth, and the factory seems to hold its breath as testing begins in full force, because this is where every shortcut, every tiny imperfection, and every hidden flaw finally reveals itself under bright, unforgiving light. Each finished bulb is guided onto the aging rack, a towering structure that stretches like a glowing wall across the factory floor, sometimes carrying 10,000 bulbs at the same time. When the power flows in, the rack comes alive instantly, flooding the space with an intense, uniform brightness. The sudden glow feels almost theatrical, like curtains lifting on a stage made entirely of light. This step isn't rushed because time is part of the test. The bulbs stay on for hours, sometimes longer, to simulate real-world use long before they ever reach a home or office. Heat slowly builds, and that heat tells a story. Weak components show their limits here. A poorly soldered joint might flicker, a stressed driver might dim unexpectedly, a flawed LED chip might fail altogether. The goal is simple but strict. Only the strongest survive. Technicians move calmly along the rows, eyes trained to catch even the slightest change in brightness. A bulb that hesitates, pulses, or goes dark is immediately removed without hesitation. There's no second chance at this stage. Every glowing point of light represents consistency, reliability, and safety. The hum of electricity blends with the quiet footsteps of inspectors, creating a steady rhythm across the floor. The air feels warmer near the racks, a reminder of how much energy is flowing through those tiny components. From a distance, the racks resemble a city skyline at night, dense and glowing, perfectly ordered. Up close, each bulb feels individual, each one proving it can handle the job. This process also stabilizes the bulbs, weeding out early failures before customers ever see them. It's a silent promise of longevity. Watching thousands of bulbs burn steadily at once is strangely calming despite the industrial setting. The light is clean even and reassuring. In that moment, the factory doesn't feel like a factory at all. It feels like a place where reliability is forged, one glowing bulb at a time. Final touches, polishing and packing. After testing, the bulbs move to the final stage. Covers are cleaned, smudges removed, and each unit is checked one last time. Then they're packed, rows of clean, tested bulbs ready to be boxed up and shipped around the world. It's hard to believe that just minutes earlier, these bulbs were a pile of plastic, aluminum, and silicon. Now they're ready to light homes, offices, shops, and streets. The whole process, from raw material to glowing bulb, is a stunning dance of heat, precision, and light. And when it's scaled up to 1 million units a day, that's not just manufacturing, that's brilliance in motion. LED bulbs might seem simple, just a light source, right? But behind every glow is a story of engineering, design, speed, and human ingenuity. From heat sinks to chips, from plastic domes to glowing walls of light, each one is a little miracle of modern production. And the fact that 1 million of them are made every single day? That's the kind of stat that deserves respect. Like this deep dive? Hit the like button, subscribe for more jaw-dropping factory processes, and don't forget to ring the bell so you never miss a production story again. Let us know in the comments what product you'd like to see made next.